Good morning, children. Nice to meet you through this video again. Hope you did your test well today. Today we are going to start with a new chapter, chapter 7, sound. Chapter 7, sound. Okay, so the previous chapter we saw was light. Okay, so these are all forms of energy. We saw light. So how will the definition of light go? Light is a form of energy which causes sensation of, previous is not light, the fifth chapter, okay, sensation of vision. Okay, light means it's a form of energy which causes sensation of vision. Heat, if they ask you the definition of heat, you will write it is a form of energy that causes sensation of hotness or coldness. Okay, so it's because of heat you feel either hot or cold. Okay, the same way we are going to see sound. We're going to see sound. Sound is a form of energy that causes in us the sensation of hearing, that enables us to hear. Is it clear, children? So all the definitions based on the sensation. So light causes sensation of vision, heat causes sensation of hotness or coldness, sound energy causes sensation of hearing. Okay, so in this chapter we are going to see about sound, sensation of hearing. Okay, so the first one, the definition of sound. What is sound? Sound is a form of energy which causes sensation of hearing in our ears. Okay, let us recollect some of the important facts about sound that you have studied in lower classes. First one, sound is produced by vibration of bodies. Sound is produced by vibration of bodies. For example, so if I have a string like this, okay, a stretched string, and if I vibrate it, okay, if I vibrate it, then I can hear a sound. Okay, you may not be able to hear. Okay, so this is called vibration. Okay, if you take a rubber band, it will vibrate for a while and then stop. If you take this rubber band, it's a stretched rubber band. When I vibrate it, okay, you can see it actually. Okay, when I pull it, it will be vibrating and then you hear a sound. So the first conclusion is sound is produced by vibration of objects, or you need a vibrating body to produce sound. Okay, so what do the instruments do? Different types of instruments and devices are used to produce sound. You take a guitar, there will be so many strings in that of different thickness, and when those are set to vibration, you hear some sound. If you can play it properly, you hear a musical sound. Okay, the second point that we have, that you should know about sound is we all also produce sound, right? How is it produced? We have something called voice box, which is also called larynx, located in the throat at the upper end of the windpipe. Okay, end of the throat and beginning of windpipe, there is a voice box called voice box or larynx. It produces sound. Okay, now how is sound produced in that? In the voice box, two ligaments called vocal cords. Okay, two ligaments means something like a flexible, okay, something like a flexible, you can imagine like a flexible wire kind of a thing. Okay, so this can vibrate. Okay, so depending on the amount of air coming, this will vibrate and sound comes out. Okay, two ligaments called vocal cords, okay, these are called vocal cords, are stretched. Okay, these are called vocal cords. It is stretched across the larynx such that it leaves a narrow slit between them for the passage of air. There will be a narrow opening between them through which air will pass. When the lungs of a person forces air through the slit, vocal cords vibrate and produces sound. Okay, this is how we are able to produce sound. Main thing is voice box or larynx. What does it have? Vocal cords. They vibrate and we hear sound. Okay. The next conclusion that we are supposed to know is sound needs a medium for its propagation. Sound needs a medium for its propagation. It can be a solid, liquid or gas. Okay, sound can be, the medium can be solid, liquid or gas. Sound can travel through solid, liquid and gas. But it cannot travel through vacuum. Vacuum means absence of a medium or space. Okay, as you know, as you go higher and higher into space, okay, you know, air will become lesser and lesser. Beyond a point there will not be any air, then you called it space. Okay, you'd have heard this thing, you cannot in space, you know, people who go for spacewalk and all, they cannot hear each other. If one person speaks, the other person cannot hear. Even in moon also they say, surface of moon, people go to surface of moon, so they cannot hear each other because there is no medium there, or there is empty space or vacuum there, so sound cannot travel through that medium. Okay, then the next conclusion, speed travels with this finite speed in the given material medium. In every medium, speed travels with a particular speed. The speed of sound in a medium depends on its density and elasticity. Density and elasticity. Elasticity, understand how much it can be stretched. Okay, rubber band has elasticity. And then density, you know, mass per unit volume. Okay, so these are the two things that affects the speed. Okay, density and elasticity. Okay, speed of sound is maximum in solids, less in liquids and least in gases. Maximum in solids, okay, and less in liquids and least in gases. And they have given the speed of sound in air. In air, speed of sound at room temperature is about 340 meter per second. Okay, whereas in water, the speed of sound in water is 1450 meter per second. Meter per second. And then in metals like steel, it's much more higher, somewhere near 2500 meter per second. In air, it is very less, 340 meter per second. So this is the speed. So compare, it is maximum in solids, followed by liquids, and the least in gases. Okay, and then you should know the value of speed of sound at room temperature in air. Speed of sound in air at room temperature is 340 meter per second. And another thing, speed of sound increases with increase in temperature. This conclusion also you should know. Speed of sound increases with increase in temperature. Now, sound energy is propagated as a wave. Sound is generally propagated as a wave. Okay. In fact, sound waves are longitudinal waves in which alternate zones of compression and rarefaction are formed. In a wave motion, the medium particles oscillate to and fro about their respective mean position, but sound energy as a whole propagates in all directions throughout the medium. Okay, sound waves generally propagate as a wave. Now, how do you understand a wave? Simply, if you throw stone, okay, in still water, there is water in a lake or something, you are sitting in the sides, okay, side of a lake, shore of a lake or a pond, and the water is so still, and you're throwing a stone. Okay, you're throwing a stone into it. Have you seen the water going like ripples? Like this, then it will die off. If you throw a stone here, in all direction, these ripples will go and then they will stop. Now, this is called a wave. This is called a wave. Okay, so if I draw in a graph, a wave will look like this. Okay, so it has regions of higher amplitude, in the sense it goes high to one height and then it comes low also. Okay, so this is a wave. Wave is a periodic repetition. Okay, the same format will keep repeating. That is called a wave. It's a repetition of a particular format, particular form of thing, one after the other, is called a wave. Okay, so in the next class I'll be going in detail about characteristics of wave motion. Today I'm stopping with this. Okay, so today we have done only introduction about sound. Based on this, I'll be sending some questions along with this, so please write the answers and send it back to me. Thank you, children.